Hi, hello, and welcome to the first section of the Data Analysis with Pandas course. In this Pandas first section, we learn about the basics of Pandas data structures. Pandas is a powerful data analysis package built on top of numpy and provides an efficient implementation of a data frame. Data frames are essentially multidimensional arrays with attached row and column labels, and often with heterogeneous types and or missing data. While Pandas adapts many coding idioms from NumPy, the biggest difference is that Pandas is designed for working with tabular or heterogeneous data. NumPy, by contrast, is best suited for working with homogeneous numerical array data. It also offers a convenient storage interface for labeled data. Pandas implements a number of powerful data operations familiar to users of both DataFrame frameworks and spreadsheet programs. Pandas, and in particular its series and DataFrame objects, builds on the NumPy array structures and provides efficient access to data munging tasks that occupy much of a data scientist's time. Pandas objects can be thought of as enhanced versions of NumPy structured arrays in which the rows and columns are identified with labels rather than simple integer indices. Pandas offers three fundamental data structures: the series, data frame, and index. A Pandas series is a one-dimensional array of indexed data. The essential difference is the presence of the index. While the NumPy array has an implicitly defined integer index used to access the values, the Pandas series has an explicitly defined index associated with the values. This explicit index definition gives the series object additional capabilities. The Pandas series can be constructed from the constructor pd.series. Data and index are the two important parameters to construct the series object, where index is an optional argument and data can be one of many entities. The next fundamental structure in Pandas is the data frame. The data frame can be thought of either as a generalization of a NumPy array or as a specialization of a Python dictionary. Here, the columns names means the names used to represent the columns, and index names means the names used to represent the row index of the data frame object. If a series is an analog of a one-dimensional array with flexible indices, a data frame is an analog of a two-dimensional array with both flexible row indices and flexible column names. Just as we might think of a two-dimensional array as an ordered sequence of aligned one-dimensional columns, we can think of a data frame as a sequence of aligned series objects. Here, by aligned, we mean that they share the same index. Both the series and data frame objects can have an explicit index that allows us to reference and modify data. This index object is an interesting structure in itself, and it can be thought of either as an immutable array or as an ordered set. The index object in many ways operates like an array. One difference between index objects and NumPy arrays is that indices are immutable, that is, they cannot be modified via the normal means. The index object follows many of the conventions used by Python's built-in set data structure, so that unions, intersections, differences, and other combinations can be computed in a familiar way. Here I have highlighted the index of the DataFrame object to show that the immutability of this explicit index object makes it safer to share indices between multiple data frames and arrays without the potential for side effects from inadvertent index modification.